Hi, welcome to howtostats.com. In this video I'm going to demonstrate something relatively easy, which is a Pearson correlation. So this is very basic univariate analysis that is performed very frequently and is a very useful statistic and actually forms the basis of a large number of other more sophisticated useful statistics like multiple regression and factor analysis. Now, when you're interested in performing a Pearson correlation, typically you should be performing your analysis. You have a hypothesis that one variable is associated with another variable, and that could be a positive correlation or a negative correlation. And a Pearson correlation is one method of estimating the association between two variables that are scored on a interval or ratio level. In this case, I've got a sample data set that I pulled up from the samples in SPSS. It's called bankloan.save, and it's got some it's got an age variable with people's ages in years, and it's also got an income variable. And my hypothesis is that older people will tend to have larger incomes. So I'm expecting a positive correlation between age and income. As age increases, income increases. So to calculate a Pearson correlation, go into Analyze, Correlate, Bivariate, and you put your age variable into the variables box, and household income in thousands, income, goes into that box. Now, in the bottom here, we've got correlation coefficients, and Pearson is the default, which is checked. And there's also a couple of other ones, and I'll do separate videos on those. We got test of significance, two-tailed, and flag significant correlations, and that just means it's going to put an asterisk next to the correlation if it's statistically significant. That's not especially useful when you're only doing with a single correlation, but when you have a correlation table, it does become more useful. So I click OK. We can see the syntax at the top of the output file. This is how you perform. This is what you have to type into the syntax if you were to go through the syntax editor. And we have the correlation table right here, and this is actually the totality of the output. We have a correlation matrix, so the correlation is actually reported twice, but it's actually the same value. It's the same estimate of the same effect. So age in years correlated with household income in thousands is 0.476, and there are two asterisks here, and you can see at the bottom of the table two asterisks. Correlation is significant at the significant at 0.01 level. In fact, it's less than 0.01. You can see that the significance level is 0.000, and you can double click that to see the sample size is very large, so it's going to be a very large. It's in scientific notation, but we can see that at a very statistically significant, it would be something like p equal 0.0049 times zeros at 0.25 level of significance. So anyway, definitely less than 0.05 and less than 0.01. It's even less than 0.001. And the final piece of information is the sample size. So we get the correlation to 3 decimal places. Usually you'd only ever report a correlation at 2 decimal places. You got the significance level, p less than 0.001. And you have the sample size of 850. And it's duplicated. That information is duplicated here. It's simply saying the correlation between household income in thousands and age is in this section of the matrix, and the correlation between age and household income is in this section of the bottom, the lower portion of the table, and the higher portion. And age in years and age in years. This number 1 here represents a perfect linear correlation between age in years and age in years. It's really just it's an effect of having a matrix that that SPSS is having to output age in years correlation and household income with household income correlation. It's basically nonsense information, but it's just it's included in the output. It doesn't give you any significance level or anything like that. So this is how you perform and identify the results associated with a Pearson correlation in SPSS. Thanks for watching.